The concept of searching is very important in computer science, and SNAP provides blocks that already allow us to manipulate lists as well as to search within lists. For example, there is a contains block that will return whether or not a certain value or thing is inside of an existing list. So with contains, I pass in a list structure and the thing that I'm looking to find. So here I'm building a list of numbers, and I'm checking to see whether or not that list contains a specific number, such as 100. And the contains block returns a predicate of true or false. And in this case, the very first list there has 100, so that first contains would return true. The second one, I'm looking for the number 20, which would return false. So if I try to display the result of using the contains, I'm just copying this contains block. It's a little bit long here, trying to put it in the right spot. Let me just move it over here now. This should return true, or say true. And if I do the same thing for this second contains block, this one should return false, because the number, let me recreate this here, the number 20 is not in that list. So 100 is in the list, so we should get true for that. And if I look for 20 in the second list, I should get false for this. So if I run this program, I can verify that that happens, true and then false. The thing about contains, though, it just returns the predicate whether or not something exists or is contained in another inside of a list. It might be useful to actually know the location of where the element I'm looking for can be found in the list. That is, I can return the index of the first place where I found a certain number. So let's create a new block of our own called search. That will be a reporter, and it will report back the index location of the first occurrence that a thing appears in the list. So the input will be twofold. Here we have a list coming in, and I like to put my element or my thing first. So I'll put that as my first parameter. I'll just call it, in this case, an item. So I'm looking for a certain item in a list. I'll just keep this as any type. So this search will work with numbers or with characters or any other type. So it's not limited just to numbers. So if I go in, I need to make an index. So this will be the counter throughout the loop that processes the list. So I come back and edit list now, edit the search block now. I want to set my index to 1, as I've done in the past. I'm also going to then create a repeat loop that will loop through the number of elements that are contained in the list. So here is a repeat that's fixed at 10, but I will change it to use the list block that returns the length of a list. So in this case, I want to loop throughout the length of a list just being passed in. And what I do is at each index that I'm looking inside of that list, I want to see if that index is equal to the value that's in the list, or the item that I'm searching for is equal to the current index that I'm looking at in the list. So I want to see if the item that I'm searching for is equal to the current item in the list as pointed to by this index counter. So item index that's inside here of a list. So if it's true that I found the first occurrence of the item, I'm just going to return back to the block that called it that index where it was found. Otherwise, if I also need to increment change by 1 so that I'm looping through every element of the list through this index counter. And if I reach the end of this loop and I have not yet found the item I'm looking for, it must mean that that value doesn't exist. So in this case, I'll return a -1. So this is an index that's not even valid, so there is no -1 index. So -1 indicates that the item was not found. Otherwise, anything other than -1 would be +1 or above, indicates the location of where that item was found in a particular index. So I'm looping over the list, checking to see if the item I'm desiring is within the list. If I find it, I report back the index. Otherwise, I report back -1. So let's take this new search block that we created and replace the call to contains with this block. So here I'm searching for the number 100. So instead of returning true, this should actually return the number 3, because the number 100 is the third index in this list. Likewise, for the second call here, if we want to search for the number 20, which doesn't exist in the list, this should return a -1. So if I put 20 here, this call should return a -1. So if I go ahead and run this snap program, 3 is the right index, and then -1. So the topic of searching and sorting is very important in computer science. Lists allow us to explore that idea, and when we come to the lesson on algorithms, we'll look a little bit deeper at the concept of searching, as well as exploring how we can sort values that are inside of lists.